Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And it's called Corners. Oh, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Corners Are Cornering by Flinty, and here are the rules. We have chaos construction, where the grid has to be divided into 6 regions of orthogonally connected cells. And what does it mean to be orthogonally connected? It means you can go from any cell in a region to any other cell in that same region just by going through edges, all while staying within the region. So this would be a valid orthogonally connected region. This would not be, because you have to go through a corner to connect to any of the other cells in the region, or go outside the region, which is not allowed. And each row, column, and region has to contain the digits 1 through 6 once each. We have internal x sums, where a digit x in a cell containing a number n in its top left corner indicates that cell sees x digits in its region, including itself, and that those digits sum to n. X counts to the sum also. For digit x in a cell with a question mark, that cell sees x digits in its region, including itself. Okay, so basically, yeah, it's basically summing to something we don't know. 1, 2, 3, 4, 5, 6, 7. Okay. Interesting. So that means this cell. So as an example, what's a good example? Let's say this was 3. That means this cell, well, we celebrate because 3 in the corner, can see 3 other cells in its region. And what does it mean? Okay, so region borders obstruct vision. Include cells see orthogonally and not diagonally. So that means it can only see vertically or horizontally only. It cannot see diagonally. So this sees 3 cells in its region, which must add up to 10. So it could be something like this, which would, again, it could be like 2 and 5. And this would be valid as long as the region does not include other cells that this can see. Yeah, and so that's essentially an example of how these internal x sums work, right? This cell, the digit in the cell, is the number of digits that this in the same region that it can see, including itself, and it sums those digits that it sees sum to the number in the upper left corner, which is 10 for that case. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, to add up to 21, it must see all 6 cells, right? 1, 2, 3, 4, 5, 6 adds up to 21. So this sees all 6 cells. It could not be the same as this direction. So it can't be all 6 this way, because these would then be both 6, seeing 21, if that were the case, because they would be the same region, right? Same with this. This cannot be all 6 this way. So it's at least 1 this way and at least 1 this way. We're not sure which. Let's draw boundaries. I guess we can mark like dark ones. So this one is definitely 6. And it sees some direction this way and some direction this way. This, to add up to 16... it cannot see 5 digits. If it sees 5 digits, that would be 1, 2, 3, 4, 5, or 1, 2, 3, 5, 6. neither of which add up to 16. One adds up to 15, the other adds up to 17. And you can never add up to 16 with 5 digits. You can't add up to 16 with 4 digits, with 3 digits either, because 3, 5, and 6, which are the maximum you could have for 3 digits, adds up to 14. So this must be seeing 4 digits here. I don't know which way it's... And it sees... For 4 digits, to see that many... What can it be? It's 16, right? So it has to subtract out... It has to be... The other 3 digits must add up to 12. Which means the 2 digits that it doesn't see add up to 5. So it has to see a 6. So that means it has to go this way at least once. Because it can't see a 6 going 4 this way. So it has to see a 6 somewhere. It must go once here. 5 can only see 2 cells. If you have tried to see 3 cells, that's 1, 2, and 3 at minimum, which adds up to 6. So this sees 2 cells here. And it must see a 3 in one of these 2 spots. We're not sure which. This then can't see... Well, it couldn't see 2 cells anyways. So this is either 3 cells or 4 cells here that it sees. We're not sure which. Oh. This has to be 2 and then going this way, right? Or 2 and going this way, because it only sees 2 cells. So these are part of the same region. So this could see up to 5 cells. No. If it sees 5 cells, that would add up to 20. So this is part of the same region. Because it must go this way and turn, or this way and turn. This can't see 5 cells, because if it sees 5 cells, it would see all the rest besides 2, which would be 21, minus 2, which is 19. So this cannot be 3 cells, because the 3 is here. So then this has to be 4 cells that it sees. So this sees 4 cells. It sees a 3. It sees 3 and sees 4. So the remaining digits that it sees must add up to 6, which is 1 and 5. So it must see 1 and 5 here or here. We're not sure. Okay, if it sees this way, I guess this could see 5. That is possible. Oh, it doesn't have to go that way. It could be 1 and 5 technically there, right? And then 6 there. That is possible. Anyways, remaining digits in column 6 are 1, 2, 3, and 5. We need to have a 4. And 4 cannot be here. So where is the 4 for the blue region? It must be here, which means this can't be 4. So this is 3. So this is 3 cells to add up to 10. It must be either 1, 6, 2, 5, and those are the only possibilities. So if it's 1, 6, this can't be going 3 this way. It could go 3 that way. If it's 2, 5, it has to be going this way then. This is 3, so this cannot be 3 here. Which means this must be 3 going this way. So then that's this. So this is green. And this is a border. Interesting. Red cannot go all the way here. So we have 1 and 5 that it sees somewhere here. Could be these combinations, and that would be 6. Or 1. Oh, it cannot go 1, 5 that way. Because if it goes 1, 5 that way, this would have to be 1 or 5. It cannot see 5 cells in the region. It cannot see 1 cell in the region. Oh, so this can never be 1, right? So this is 2, 3, 5, or 6. This can't be 1, 2, 3, 4, 5, 6. So it cannot go both here because that would not see 5 cells in the region. So it must go at least once this way. It could be 1 that way and that one that way, or both this way. So this is 1 or 5. Remaining digits in row 1. We have 1, 5, and 6. Remaining digits in column 1. We have 1, 4, 5, 6. No 4 being here. Remaining digits in row 6. Did I say? I meant column 1. I don't know if I said column 1. 1, 2, 4, 5. And this can't be 4 because of 4 in the column. This cannot be green, so it can't close off this way. So this is a separate region, and it must exit out this way. It cannot be red, because then this would see all of these. It can't go, because it can't go do something like this, because then that would block this as a region. So this has to be a separate region, so we're going to make that pink. So this cannot go 3 this way, so it must go at least once this way. Whoops. Once this way. Remaining digits in column 2. We have 1, 2, 5, and 6. Okay. If this is this way, then this would have to be 6 there. This is not part of green. I don't think this can ever be 6, right? Can't be part of pink. It can't be part of green. Can't be part of blue. Can't be part of red. If this is not part of orange, how does it see 6 here? Well, okay, no, it could do that. No, that doesn't really work. This sees 4. It could be all 4 that way. Okay. This can't be pink. It could be red, technically. Could be orange, technically. That's not helpful. This cannot be green either. So this could be pink, pink, red, yellow. Can it reach orange? 1, 2, 3, 4, 5, 6, 7. No. This cannot be green, could be orange, yellow, cannot be pink or red. So this is pink, this is orange or yellow. Um, okay. Hmm. Oh. If this is 1515, this has to be 6. There's no other place for it. If this is 1515, it cannot be part of this because this can't be, this would have to be 6 and it does not see 6 cells in its region. So this would have to be, one of these two would have to be 6 essentially. So one of these two is guaranteed to be 6, which means this cannot be 6 here. This can't be 6 here. Yeah, the green could go something like this, right? Hmm. Hmm. This cell can be... This cell cannot be pink, cannot be red, cannot be blue. So this has to be yellow or orange. Same with this, I guess. Yellow or orange. So orange can only go up to here. Blue can go all the way up to there. Blue can go all the way up to here. This could be red or yellow. These could all be yellow, technically. Yellow could be in a lot of places. Pink can only extend 4 more. This could be red. I guess this could be red also. This could be green. So one of these two could be green. Or both. Red, red. Yellow, technically yellow could, no, yellow cannot be here. If yellow is here, pink would have to go this way, red would have to go this way, but then it's blocked here because yellow would have to extend further. So yellow can never get to here. So we have all the greens for what it can be. Orange sees 4 in these directions and 2 more. Go 2 more. Or 1, 2 technically. Blue cannot be any of these cells. And then the rest are yellow. So this could be yellow. This could be orange. 1, 2. This could be orange. One of these has to be green. So this cannot both be orange. So it can't be orange, orange. 1, 2. These could be yellow. Pink can get to here, 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 and that's it. Red can go to 1, 2, 3, up to here, here, and here. So this is red as possibilities. Hmm. Can we have a yellow there? I don't think so, right? 1, 2, well, maybe. No, you cannot. If you have a yellow here, it can only go out this way. Red would have to be 6 here, but that would block the pink in. So this cannot be yellow. Um, can this see all six? I don't think so, right? Say it did. How would that work? It cannot go here because then this would be. So if this is six, this is guaranteed not to be orange. It has to be yellow. So therefore, if we go here, that would block this cell from being in part of a region because it can't be part of green because this sees only two cells. And it can't be part of orange because it's blocking it off, obviously. And it can't be part of yellow because this must see all the cells in the region. So it can't go this way. It would have to essentially go here at least. Um, this would then all be orange. So that's four orange it would see. It would have to do something like that. And then this could see six cells. It would have to be all six cells this way. And that's too many cells for these regions here. One, two, three, four, five, six. Um, right. So this can never be six then, right? Because again, if it's six, it would have to essentially be like this. Because one of these would have to be orange. So then it would be like that way or that way. Um, well, I guess it could do that. Hmm. Is that possible? No, because then it would block this region from ever these three cells from ever having a region. So no. It cannot be it either goes all five here or it does two here and then four here, which blocks these cells from having a region. So the answer to that is no, this can't be six. That's not that helpful, I guess. This can't be red because it would have to be four reds in a row because it can't be red going this way because then this doesn't have a cell for a region. So this cannot be red. So this is blue or yellow. You could have yellow going this way because this could be pink all this way and then all four of these are red. So that's possible. Uh, hmm. Um, hmm. Oh, this sees, it cannot see, this has to see two here. So this has to be four at most, so this has to be blue. Okay, so this is not part of that blue region. Okay. Hmm. Okay, so this is 1 through 5 here. This has to be red. If this is not red, how does it get out? It can't. It only goes 3 at most here. It can't block the pink. Yeah, so this has to be red here. Okay. And whether it goes this way or this way, this is guaranteed to be red. So this cannot have 3. Hmm. Hmm. So this could be just all 6 reds there. That is possible. And you could have yellow go something like that. If you have red here, it has to be 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. No, it can't do that. Can't be 1, 2, 3, or it has to be 1, 2, 3, 4, 5, 6 that way, right? So that's fine. Then this would all be blue, so they had 4 blues there. How many yellows and oranges are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we only have 3 more yellows and oranges. But that could be in quite a few places. So, oh wait, this can't be pink. If we tried to force this to be pink, then the problem is green wouldn't be large enough as a region, right? Because it can't go 1, 5, 1, 5, 6. Can't go 6 there. Or 6 there in that case. So this cannot be pink. Well, pink then is here, or it has to exit out this way. And because of that, this has to be guaranteed to be pink, right? If we tried to go out without this being pink, the problem is that would block the red region because it can only see 3 cells. So this has to be pink here, which means it can't be green, which means this must be green, green as a pair. So this is, I don't know what color that is, green, and this is green. And this is 1 and 5, and this is 6. Right? Because this adds up to 13 for the digits that it sees. And this is done as a region. So this must be the same region as this, guaranteed. But we don't know if it's yellow or green. Or sorry, yellow or orange. Because it could be 4 here and then sees those 2. So either way, I don't think this can ever be 5, right? It could be, I guess. Be 5 like that, or 5 like this, or something. Yeah. Pink is here. Pink needs access to a 3, and it cannot get access to a 3 if all of these are pink. So it must go to here. So this is pink. This sees either 3 or 4 digits. Right? It sees 3 this way, or it sees 1 this. And it sees 3 guaranteed here. It could see another one here. So this is 3 or 4. We know this is a boundary. We know one of these has to be red. One of these is red, one of these is... at least one of these is red. So this cannot be red. Therefore, this is yellow here. So can this ever be yellow here? 1, 2, 3, 4, 5, 6, 7. No. So therefore, this can never be yellow, so it must be orange, which makes this orange. And this must see, so these are 4 oranges, so these can't be orange. So this has to see 1 orange in one of these 2 cells. So these cannot be orange, these are guaranteed yellow. So this sees 3 cells, so this is 3. And one of these is a 2, we're not sure which. This can't be 3 because of 3 in the row. This adds up to 16. This sees 3 or 4. We have a 1-5 pair, which eliminates 1 and 5 in the rest of the column. So this can't be 1-5. It's a 2-4 pair, which eliminates 2 and 4 in the rest of the column. So this can't be 4. This is 3. This sees 3 cells, so this cannot be pink. Therefore, one of these is pink, one of these is red. And this is a boundary here. One, 5, 1, 5. So there's going to be a 6 in one of these and a 6 in one of these. So the red has its 6 already. It could be 1, 2. So it sees only one of these 2. Right? To add up to 10. So either there's one of those, 1, 2, 3 there, and then that's red. Or it's 1, 2, 3 here. And then this would be pink, so this would be red. So this is always going to be red. And since this is red, this can't be red here. This is pink, which means this is all red. So then it can't be red here. This is not yellow. This can't be red. That's yellow. This can't be yellow anymore. This is blue. We're done with those regions. We have 1, 2, 3, 4, 5, 6. So this can't be yellow. This is blue. That's done as a region. So this has to be yellow here because it can't be red. Because this sees only 4 cells. So this must be yellow here, which makes this orange. Okay. So this is not yellow. This is not orange. So therefore, this is a 2. This is 2. This adds up to 10, so it must be 2 and 5. This can't be 2. That's 4. This can't be 2 or 5. This has to be a 1, 6 pair. So this can't be 1, 4, or 6. That forces this to be 5 here. There's no 5 here, no 5 here, no 5 here. This 5 eliminates 5 here, so this is 1, which means this can't be 1. That's 5. This 1 eliminates 1 here, so it's 6 and 1. So this can't be 1, 5, or 6. It's 2. No 2 or 5 here. So this is 1, 4, which eliminates 1, 4 in the rest of the blue region. So this can't be 2 or 5 because of a 2, 3, 5 triplet in the column. So this is 1. No 2 or 3 here because of 2 or 3 in the row. So this is 5. This can't be 2 or 5. So it's 3, which makes this 2. This can't be 1 or 6. It's 4. This can't be 1 because of 1 in the row. It's 6, which makes this 1. That leaves this as 2. This can't be 5, so it's 1. No 1 here or here, so this is 4. That's 1. Remaining digits here are 4 and 6. This can't be 4 because of 4 in the column, so that's 6 and 4. This can't be 1 or 6. It's 5, which means this can't be 1 or 5. It's 6, which forces this to be 5 and this to be 3. And that's the solution. Thank you for playing. Well, thank you for setting. That was fun. I don't know. I don't know if I would consider this easy. Even for a 6x6, this was the logic behind how you eliminate these sets or where regions can be is kind of, the logic is not easy. I would say it's challenging level. And even though this is only a 6x6, it's still pretty challenging. So I think I would put this at challenging level. Chaos construction rule sets, especially 9x9 chaos, are usually fairly difficult, at least challenging. I was thinking that maybe a 6x6 would be a little easier, but this one, I don't know. The logic behind it is challenging level. Execution wise, it's not so bad. So maybe that's why people put it as easy. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.